Okay, that's number 4. You're asked to find the initial velocity. The final velocity is, of course, 0 because it stops. And it says it's a deceleration. How else can something stop? So it has to be a negative, right? So it's deceleration. And then delta x is 30 meters. And from your formula sheet, you should be able to see this equation.
I always forget the square.
Oh, please don't. And so,
Oh, yeah, there it is.
yeah.
I can never.
What did I do? Something. Okay, so V naught squared is. Why did I even put 30 here? So give me that, please. 30 times 3.5 times 2 gives you something, and then when you take the square root, you get 14.5 meter per second. Can you also give me that number? Square of 14.5.
No, it's the square of 210.
Is it
14.5.
And that gives you 14.5.
Yeah.
210?
Yeah, it's
The
200.
Oh.
Oh, it's
square is
yeah, yeah,
200.
it's the square of 200.
All right. Okay.
Square root of
Right. Hold on, Jose. So in this question, xt is minus 3 without the units, minus 3t plus 1t squared. When t is 0, of course, everything becomes what?
0.
So x at 0 is equal to 0. And when t is equal to 4, x at 4 is equal to, somebody should have got it, so please tell me.
1.
Just one?
Oh, hold on. X of 4 is 4.
4?
Yeah.
All right, I want to save time. So 4 meters. So that means that
12 plus 16.
Well, since it's talking about
that
speed,
means the total distance. What is the total distance traveled? Hold on. What is the total distance? 4 meters. And in how many seconds?
4.
4 seconds. So that means the average speed is 1 meter per second. Done.
okay. But
And that,
saying speed,
mm.
should we ignore the negative?
Hmm?
Because I thought,
Ignore what negative? In the function?
yeah.
No, don't do that, please. No.
Okay.
Total distance by total
Position
time.
function, right?
Yeah.
Okay.
A position can be negative. So I just wanted to complete this, that's all. So you get 1 meter per second, right? And every question you're asking me is also being recorded, Zach. Okay, on that other question, I just made a mistake on the calculation right here. So you got to see that I've changed it now. It's negative 6.8. So when you put that there, you get 9.15 meter per second. Sorry, that's just one of the 100 mistakes that I make. So I'm trying to put this on YouTube too. And so I'll be fine.
That's amazing.
So a child throws a ball with an initial speed of 8 meters per second at an angle of 40 degrees above the horizontal. The ball leaves her hand 1 meter above the ground. What is the magnitude of the ball's velocity just before it hits the ground? In this case, you're only asked to find the magnitude, not the direction. So that's a point. So if I had asked, what is the ball's velocity? You have to find both magnitude and direction, just saying. So here's the diagram coming up. That is the direction of velocity that is shown 40 degrees above the horizontal. So that vector is how much? 8 meter per second, isn't it?
Yes.
So delta y is -1, that's 8 meter per second. Resolve it into horizontal, 8 cosine 40, of course, and the vertical is 8 sine 40.
Yeah.
And 8 cosine 40, I think, is 6.13. Sine 40 is 5.14.
Yep.
So that's the first thing you do. And then what are you asked to find? The magnitude of the ball's velocity just before it hits the ground. So give me the physics. Diagrams are important. Writing down what's given is important. Making a plan is very important. You just don't go with the first equation that comes to your mind. You know, you have to, what are you going to do? How do you find the ball's velocity before it hits the ground? Here. Talk. Isn't that what you're looking for? Just before it hits the ground, it's going downwards. You want its velocity. Do you remember that the horizontal velocity never changes?
Yes. Yeah.
So just before it hitting the ground, it hits the ground, the horizontal velocity is still going to be 6.13 meter per second.
Mhm.
But the vertical component changes.
Yes.
So what you're actually trying to do is you're trying to find the final vertical velocity, which will be downwards. And once you get the horizontal and the vertical, you can find the magnitude by simply taking the square root of the sum of their squares. That's the plan. Did you get the plan? So for every problem, make a plan. So you know what to do. So now we're going to find the vertical velocity. To find the vertical velocity, we know A is negative 9.8. And there is the diagram. The horizontal is 6.13. But the final Y velocity is what we do not know. See?
Yeah.
Trying to find that. And to get that, we're going to use this equation. We know that the initial is 5.14. Isn't the initial positive? Because it's upwards, positive, and then minus 9.8 times t. I wish I had known t, so I don't. I'm just trying to do it the way a student would approach it. You see what I'm doing?
Yeah.
You have your plan, and then you go, okay, I need, and then you get, oh, I don't have the time.
But we can find that.
So then you go and say, and let's find the time. So to find the time, use this equation, again the vertical, substitute the numbers, get that quadratic equation, solve the quadratic, minus b plus or minus, square root b squared minus 4ac by 2a. Get that, and then substitute all the numbers properly. And I got 1.22 seconds. Did anybody else get that? Did you get to that stage?
I didn't resolve the project.
Okay.
Really.
Once you get that time, put it back into this and find the final velocity. Right? And once, after you get the final velocity, what do you do? Oh, that's in green faded ink. You can see it right there. It's coming out. See? Square both of them, add them, take the square root. There's your answer. Done. Boom. Time later on. So, is the formula given on your formula sheet as G caps M, small m, divided by capital R or small r? All right. So that's the formula for gravitation, gravitational force. And you're given the constant, universal gravitational constant. It's given. You're given the two masses, both 82 kilograms. Oh, I don't know how that happened, both having the same mass. And standing 7 meters away. And then you just need to know how to put this into your calculator. Okay, so what do you get when you do this? I did not hear the last part. Is there 9.9?
9.15
Times 10 to the negative 9 newtons. Oh yeah, very good, newtons. Okay, so here are the forces, the weight mg, and Fn is the normal force. There is no friction. And now you got to tell me, which one of these forces is along the y-axis? One of the forces is along the y-axis. Which one? Which one of these two forces is along the y-axis? mg. See? So you don't do anything to that. But look at Fn. It's neither along the x nor the. So that's the difference. Remember, in an inclined plane, we would break the mg into two. But now we break the Fn into two. That's the difference which you have to remember. There's no shortcut to that. You just have to remember that. So you break that into its vertical and horizontal. So, and if this angle is theta, you have to remember this is theta too. So therefore this would be Fn cosine theta And this would be Fn sine theta. Do what you have to remember that. So now it's very clear that Fn cosine theta, come on, is equal to what? Look at the diagram, tell me. Fn cosine theta is equal to what? mg. And Fn sine theta is what gives us the centripetal force. Okay, hold on. Somebody tell me, on which side is the center of this curve? On the left side or the right side? On the left. So this is an arc. I'm going to destroy my diagram, but it's okay. That's the arc, kind of. And the center is somewhere here. You all with me? Or to be perfect, the center is here. And that means you can see the Fn sine theta is towards the center. Watch this. Isn't this towards the center? That is the centripetal force. Correct. So Fn sine theta is equal to mv squared by r. That's how you get that equation. So now you divide one by the other. The Fn will cancel. What is sine theta by cosine theta? Tan theta. And that's how the masses cancel. And you get v squared by rg. See? That's how you get that formula. If you remember, if you don't know that, then plug it into this equation and just calculate. So in this one, tan theta is 21.5 squared divided by the radius is 110. Do you need the mass of the car? You don't. You don't even need the mass of the car. It's independent of the mass. You can't have different banking for different cars. That would be impossible. What do you get for that? When you do this, I think you get 0.4288, right? And then you got to take the inverse of that. What? That is tan theta.
No, like dividing the versus 2.75 divided by 1078.
Mm-hmm.
It's 0.042?
0.42.
Oh, sorry,
Zero.
I thought you said 0.042.
No, you're not listening. Okay, so when you do that, you take the inverse of that, you get 23.2 degrees. Is that what you get? Somebody?
Yes.
That's how you do that problem. Done. Hey, what were the key points in this? You can only do what I did if it's a horizontal unbanked curve. Did you all hear that? Horizontal unbanked. So we know friction is equal to the centripetal force. And to get friction, you have to have Fn is equal to mg. Goodness. That's all you have to do. And pay attention. So this is a system of two connected objects. We have to look at each one of them individually. Okay, I know they're connected, but you got to look at each one individually. So that's my 5 kilogram there, represented like that. What are the forces that act on that 5 kilogram? Of course, its weight, right? Now, what are you talking? Does its weight act vertically down? What is the other force? The weight is the gravitational force. Tension in the string. So you have two forces. mg, we'll call it m1g. Because this is m1 for us, this is m2. Did you label them the other way? Doesn't matter. Yeah. And this is the tension. What's the symbol for tension that we use? Ft or T? T. Whatever. T. Okay, so now stop right there and tell me, which one of these two forces is bigger? What direction is this mass moving in? The 5 kilogram, is it moving up or down if you let go? Down. If it's going down, that means the force in the downward direction is bigger. Is that clear? So when you take the net force, you go the bigger, take away the smaller, so that will be m1g minus t. You see, I told you why I did that. Did you hear me? M1g is bigger than the tension. Why? Because it's going. So that's the net force, and net force should be equal to mass times acceleration, correct? Mass times acceleration, Newton's second law. Net force is equal to mass times acceleration. That's what I've used. Is that clear? What I've written, is that clear? Okay. So substitute the numbers, whatever we know, 5 times 9.8. And don't go negative 9.8 there, please. We do not know the tension, do we? We do not know the acceleration. So that's our first equation. That is our first equation. Now, what direction is the second object moving in? Up or down? Up. Therefore, oh wait, I didn't even draw the forces. What are the forces acting on it? M2G acting down and tension acting up. And remember, it'll be the same tension because it's one string. The tension will be the same, but this one, of course, would be M2G. Which one of these forces is bigger? T. So when you take the net force, you're going to go T minus. Why T minus? Because it's bigger. Is equal to M2A. Newton's second law. T, you do not know. M2 is 3. So 3 times 9.8 is equal to 3 times A. That's our equation 2. And the physics part is done. Now it's just math. If you add the two equations, you know why that will be good? Somebody tell me which two terms will get cancelled. Because you have minus t there and you have plus t here. See that? So if you add the left-hand side to the left-hand side and the right-hand side to the right side, that will be the easiest to do. And so now 5 times 9.8 is 49. And 3 times 9.8 is 29.4. Am I right? And then on the right side I get what? Help me out. What do I get on the right side? 8 times 8. So put that in your calculator, find that. 49 minus 29.4. 19.6 is equal to 8A, which gives, now you have to divide 19.6 by 8. That gives you 2.45 meter per second square. Yay!
So I watched one of your university physics videos,
Yep.
and
All right, this question is not asking you to find the tension, but somebody, can you go and find the tension? That's it. Because we did it this way, you just plug it into one of those equations. Any of the equations will give you the same answer. Let me use it in equation number 2. What do I get? Question number 2. T minus 29.4 is equal to 3 times A, and A is 2.4. So help me out with that, somebody. What do you get? 36.75 newtons. Now, you know, I can honestly tell you that if you do that this way, you're ready for any kind of problems on this connected system. Let me give you a twist on this one. So those are the only 3 forces acting. And how do we set up the x and the y axis? X is along the plane and y is perpendicular to the plane. So that's how we set up the axis, x and y. Remember that. And then we take one look at it and we see that 2 of the forces are either along the x or the y. Which ones? Which is the force along the x-axis? Friction is along the x. And which force is along the y? The normal force. So we do not do anything to those forces because they're already either along the x or the. So the only force that we don't like, you know what I mean, is mg because it's neither along the x nor the. So what do? We break that into its components. And then the angle is given, and that is 41 degrees. That's the angle. We need that because I know that when you break that mg into its components, you got to get one along the x. That's why I try not to draw this with you, see, because the software has its own limitations. All right, so let me draw freehand. That's along the y, isn't it? And that's along the x. Can you see it? Okay, and so now another thing you have to remember is that angle is going to be 41, and therefore this becomes mg cosine 41, mg cosine theta. And this one is mg sine theta. So that's what you have to remember in that problem. Mg cosine and mg sine. No space there. That's why I wrote it down there. You get it? If you get that, then the problem is easy. So let's focus on, remember I told you, focus on the x and the y separately. Haven't I been telling you that? Okay, let's go. Let's focus on the forces along the x-axis. Forces along the x-axis. Look at this diagram carefully and tell me what is the net force along the x-axis. Net force along the x. Net force along the x. Anybody? Mg sine theta plus F if there was friction. You know, mg sine theta plus friction. Do you see that both are along the same direction? Both are downwards? Do you see both are downwards? That's why we added them. Net force, that is the net force along the x-axis. Is that clear? Now, you may go and say, hey, that's to the left side, so both should be negative. That's okay. Because if you come up with that, then two negatives will cancel out. So don't worry about that. Don't make it more complicated. So, and according to Newton's second law, I hope you remember, net force is equal to mass times acceleration. So we use that, and then we say, okay, we got the net force, which is mg sine theta plus friction is equal to m times ax. In this particular case, friction is 0, so I'm not going to write that anymore, which means the mass can be cancelled from both sides because there's no friction. You heard me? Otherwise, you could not have. Okay, that would be a tougher question. So always remember, if there is no friction, this is a very good formula for you to remember. If there is no friction, ax is equal to g sine theta. Technically, negative g sine theta because it's down. You see that? Okay. But just taking the absolute value, that's good for you to remember for any inclined plane. Ax is g sine theta. So once you get that, what are you asked to find? Let's take a look. What are you given? What are you given? Do you have the initial velocity? Yeah. V naught. Isn't that along the x? Come on, all x quantities. So V naught is equal to 8.5. Hey, what is V final? 0. Why do you say 0? Because how far will it go before stopping? Before stopping. So, okay, do we have A now? Put that into that and tell me minus 9.8 times sine, what was that, 41? Help me out with that.
Yes.
Negative how much? 6.42. All right, so, oh, sorry. So I got A now, And what he has to find? How far will it go? Isn't that x? Okay, what's the relation between these four quantities? 1, 2, an equation that connects these four. We have not used this today. Very good, correct. This is what she said, isn't it? We have not used this equation, so use that. And left side is 0, of course. The right side, 8.5 squared. And this is going to become negative because 6.42 is negative. And then you have x. Rearrange that and calculate. So when you do all that and rearrange, you're going to get x is equal to 5.62 meters. Who got this answer on the exam? Do you remember? So here we go. If the rock is thrown at an angle of 30 degrees at 10 meters per second, you have to break it into its horizontal and vertical. Do you remember what the horizontal component is? When you use trig there, build that triangle. Is it cosine or sine? Cosine. Whatever you take the angle with is always cosine. So that would be 10 cosine 30. All right, put that into the calculator and tell me, is it 8.67?
8.6.
Which is, yeah, I just rounded it. And then the vertical component is going to be 10 sine 30, which is 5 meters per second. Check it out. So this is my VOY, this is VOX. Let us focus on the X. Is anything else known about the X? What's the only equation that works for the X? So now we know it's 5 meters per second. It's going to take a certain time to hit the water down below, isn't it? We do not know the time, do we? No. Do we know the displacement? Do we know the horizontal displacement? Do we? Isn't that what you're asked to find? Yeah, so you do not know delta x and you do not know time.
Wait, wouldn't the 8.67 be the velocity of the x-axis?
That is right, Brian. Thank you for correcting me. See, I'm sleepy. Thank you. 8.6, see, that's why I need good students like you all. 8.67 meters per second is the V naught x. I had flipped them. You see that? Okay. So what's the only equation that will work on the x-axis? And I think I lost that because I was trying to focus on which is the equation. Come on. Only one equation works on the x-axis. I'm telling you. See that? That's the only equation that works on the x-axis all the time. And what you know there is just the VOX. So let's just put that 8.67 multiplied by time, and we will call that equation 1. And then we go on to the vertical quantities. Okay, what are the vertical quantities we know about? VOY. Oh, you see, that's because I labeled them wrong. That's why I was making a mistake. Labeled them wrong. All right. So VOY is 5 meters per second. Plus 5 or minus 5? Plus 5. Why? Because it's up. So remember, Jesus had asked the question, what if it was thrown 30 degrees below the horizontal? Now this would have become negative if it was thrown below. Okay. What about A? Negative 9.8 meters per second squared. Okay. Do you know delta y? Is delta y given 20 meter or negative 20 meter? Negative 20. Why? Because it's falling down. Do we know the time? No, we don't. You see the equation that we could use? The equation that connects these four? Come on. King. So write that delta y is equal to v naught y t plus 1/2 a t and negative 20 is equal to 5 t minus 4.9 t squared. Wow. So is this a quadratic? You don't like it, do you? 4.9 t squared minus 5t minus 20 is equal to 0. Brought them all to one side, and then good if you can remember ax squared plus bx plus c equal to 0. Now you compare, and then you get a, b, and c minus b plus or minus square root b squared minus 4ac whole divided by 2a. Did somebody put all that and get the answer? Got it? All right. That's the only way to do it. I wish there was another way. Okay, so minus b is 5 plus minus square root b squared is 25 minus 4 times a is 4.9 and c is negative 20, and then I have to divide the whole thing by 2 times 4.9. All right, if somebody's done it, please give me the answer. What do you get? 2.6 seconds. 2.6 seconds. Once you get 2.6 seconds, you take it back into this equation, plug it into that equation, you would get the answer. Delta x is equal to 8.67 times 2.6, which gives you, what does that give? 22.62 meters. That is the problem. Now we need to go back and find out the speed by plugging it into equation 1, correct? You see our equation 1, we did not even use it. And so when you plug it back, you're going to get 18 is equal to Vox times 2.21. And then Vox is equal to 18 divided by 2.21. What do you get for that? 8.14 meters per second. Okay, meter per second. Good. Thank you. So keep the x and the y separate. Talk about the x. What do you know about the horizontal component of the velocity? Huh? It never changes. The horizontal component of the velocity never changes. The x component of the velocity never changes, which means there's only one equation you can always use. Remember, when the velocity never changes, isn't there only one equation you can use? What is that equation? Yeah, x is equal to, or delta x is equal to Vox multiplied by time. Come on. And in this problem, do you know x? Do you? Yeah, 18 is equal to, we're trying to find Vox. Do you know the time? No, we don't. So at least we have one equation there. We do not know Vox and we do not know time. Now let's talk about the y component. What do you know about the y? You know delta y is 24 meters. Do you know that? Be with me. What is acceleration? Along, is always negative 9.8 meter per second squared. Why is it always negative? Because it's always going down. And in this particular question and the next, it says it's thrown horizontally, isn't it? That's a key word. If something is thrown horizontally, its initial vertical velocity is 0. You got to write that. If something is thrown horizontally, its initial vertical velocity is 0. So Voy is 0. And then time. So now the thing is, could you find the time it takes to go from A to B? Could you? Yes, you could. Because you look at those quantities, You know the equation that you have to use, don't you? What's the equation that comes to your mind? Delta y is equal to v naught t, yeah, v naught t plus 1/2 AD squared. And then you start plugging it into that. That's all. So you go 24 is equal to, first term gone because it's 0, 1/2 times negative 9.8 times t squared. Oh, I made a mistake. Correct me. What's delta y? Negative 24. Why negative? It's going down, isn't it? Yep, negative 24. So, and then you rearrange that, and you, of course, you get t is equal to square root of 24 by 4.9. Am I right? Did you get the answer? Close to 5? What do you get? 5.07. Going by significant figures is 5.1, isn't it? Okay, 5.1 seconds. And you will see, looking at number 3, a car that's initially moving at 7.50 meter per second. That's the initial velocity, isn't it? So it's initially moving at. What is the symbol for that? V naught, right? Did you write that? V naught, okay. Begins to accelerate forward uniformly. So that's the acceleration. And you can see that in the unit. A is 0.550 meter per second squared. Question A, how long after beginning to accelerate does it take the car to move 3.50 kilometers? So, isn't that a distance or a displacement rather? Isn't it in the wrong units? Did you catch that? It's supposed to be in. So you have got to know now that 1 kilometer is 1,000 meters. So you have to change that. And then it says how fast is the car moving just as it has traveled that same distance. So you have to find how long means what? Time. And how fast means velocity. So here are the terms. V naught is given. Acceleration is given. Got to find the time. And that is the displacement in meters. Right? 3.5 times 1,000 gives you 3,500. And then you put the equation down. I'm trying to do the B part first. It's on your formula sheet. First, I'm using this to find the final velocity. Get it as 62.5. And then I go and do the A part using that equation. Those are the answers. So that's the that's the A part. That's the B part.